Alright, like Lisa said, my name's Joe Geis here. I've been in the carbon fiber industry since the late 90s. There's many and different applications for fiber. Today we're going to go through a few of the different layups. We're with the 200 series sheet, which is a unidirectional, which we need to know before a layup. A bidirectional will have toes going both ways. This is for a singular use in many applications, if that makes sense. So let's start from the beginning of the project. As a contractor gets awarded the job, on part of their project, there will be, if there's carbon fiber on it, there will be a line item on that. What we need to know is, A, where is the application going to be done? B, the purpose of the application. That's going to be the very most important thing for any applicator, is why are we doing this layup? So a lot of the system is directly going to be ran through the engineer on the job site. And why we need to know this is carbon fiber that's laid up wrong is just a waste of time, and carbon fiber that's laid up directly where it's supposed to be done is a great structural fix. So one of the first things we want to look at when we find out our location, so in this situation here, we got specifications that the engineer wants a U-wrap on this beam. And a U-wrap is consistent of, with the unidirectional, going around this beam support in a U fashion, like a horseshoe. The purpose of this wrap could be for many reasons, whether they want to add extra weight to the structure itself to give it more of a structural bearing, or you got B, where this beam here could have lost some structural integrity, whether there was 8 PT cables, let's say, running through it, and 2 of them are broken or lost their strength. Instead of fixing them, the cables that are broke, one of the options is to put carbon fiber there to subsidize that the structural integrity is beam. Another way is what we call a diaper technique. Is we could have possible blowout that's happening in this beam. We're just going to diaper it so that we don't have anything that falls off the beam. That's a situation where they don't need the beam in the structural matter. But today we'll just say that this has lost strength and we want to bring the strength up. So what we got to find out is, what does the engineer specify? Let's say if he says this is the column here, we're going to do a 3-foot wrap. 3 foot out from the inside of the column out. Now, we got to look at it. Okay, so our carbon fiber is 2 feet. In this situation, I think that we have 1 foot, so it worked out. So let's go 3 foot 5 inches is what the engineer specifies. So we're thinking, well, we got 1 foot chunks in the width of our carbon fiber. Is it okay to put 4 pieces on that? It's not. At any point, it's called point loading. We want to know exactly what the fix is, and if it's all right to go over, or does he want that cut at that situation? Or a lot of times the engineer will leave an area out, he'll ask for it bigger for a place for a test to be done, whether it be a pull test or not. So this is the questions with the RFI we need to find out. So if we go over, let's say, the engineer wanted that 3 foot 5 or whatever, and we lay out 4 feet of carbon fiber. So the question was, is it all right to go over and beyond the repair area? And the answer is usually not. And what that happens is this, with the structural strengthening system, the carbon fiber can give you 7 to 15 times greater value than what this concrete gives you. So overloading a beam can give you the reverse effect of carbon fiber, where it'll actually make a break point because they're making it too strong. All concrete structures have flex, and we still got to keep that in mind. So that's very important. We keep up with specifications of what the engineer wants. So we have that. We're going to go 3 foot, what did I say, 6 or 5, whatever. We're going to go 3 foot 6, okay? So now we look at the beam. We came on the project. First thing we want to look at, is there any delams in the concrete? And any kind of spalling? Is the concrete sound? That's what we need to find out. If not, that needs to be repaired first. We looked at the beam, we sounded out the hammer, we decided, yes, this is a nice, solid beam. Now we need to get into the preparation of it. For the carbon fiber to bond, we want to make sure that we're giving it a profile from anywhere from a 2 to a 3 into the 4 range, kind of pushing it. We don't want too rough of a surface to leave air voids. We need it rough enough for a bond to carbon fiber. A few ways of preparation on concrete structures could be sandblasting. In some situations that works great, others it doesn't. If we have a lot of mechanical, if we're indoors. Another one would be grinding the beam, using a dustless grinder hooked up to a shock vac and a double road diamond blade. That would open up the pores of the concrete and give you that 2–2.5 profile. The other way is hydroblast. That can be done with a 10K power washer. Of course, and then we're getting to a situation where you put water into the process where you'd have to let dry prior to installing the carbon fiber, which could take quite a bit of time. So preparation can be done many ways, as we said. So let's just say this beam here, we decide we grind it, it's done, it's profile number 3, it's ready to go. The other thing we have to look at for this U-wrap, which here's this a little sample, we'll actually put one on, is this carbon fiber is going to wrap around this corner. So we have to make sure that on carbon fiber we don't have a 90-degree corner. Most columns have either a 90, a chamfered edge, or a bull nose. And what we're trying to achieve here is so we don't have any kind of a tear point into the fabric and we get the unique pull of the fabric that we're actually going to want this bull nose. So there's 2 ways to get that done. One would be grinding a bull nose into the concrete, which I don't recommend, because if you've ever seen anybody with a grinder, to try to make this a perfect round and all the way through the beam so we don't have any voids, it's very hard. It can be done, but very hard. The other way is actually thickening the epoxy into a paste using a silica fume and taking a bull nose tool that you would use for drywall and just making your own with epoxy. Nice round bull nose. In this situation, we're going to say this is bull nose, okay? So we have the rounded edge here. This would be our ceiling top, if you can picture that. Let's say we're in a parking structure. Here's the ceiling for the next level. We're on level 3, this is level 4. This is the reason we're doing the U-wrap. It's impossible for us to go through the floor to wrap this whole beam. So this is as far as we grind up to here to the ceiling edge, all the way down, all the way through and back to the other side, and then the representation of our bulges. We have our carbon fiber cut into our locations already predetermined. Now we're ready for the epoxies. We have unit A and B. The nice thing about with Rhino carbon fiber, it's all mixed evenly, 50-50, 1 point product, and everything that you'll be doing in this carbon fiber is done with the same epoxies. That's the advantage of using Rhino. So, first of all, we want to look at is we've got a nice clean bucket. That's going to be what we call the mother bucket. And from that point, we need our 2 mixing buckets. This is going to be your B bucket, which should be labeled, and then your A bucket that should be labeled. We're going to make sure that we have 100% accuracy when this is done, because the product manufacturer design team made sure that we should be accurate to make sure that we get our 100% structural value out of this product. So this is very important that anybody that does quality control and works with carbon fiber team, this is something that you want to go over with fine detail. The mixing station is what I consider is the foundation of carbon fiber. If something's going to go wrong, it goes wrong here. And this is what we want to prevent. So, here. So we have a label A and B. In this situation here, with our temperature, we got to keep in mind is how much epoxy do we want to mix? We want to be able to get out enough epoxy and carbon fiber in the time frame allowed with the crew size we have, without wasting any and over mixing or under mixing. So it's a little trial and error. So this is what I tell everybody. On the first run of any project, you should not look at the whole beam or the whole project, we should be looking at a singular sheet. This will get them going, and we'll know what our time frame is by doing one. And then everything will be judged off your first sheet. So the whole idea is, A, we're going to mix up A and B together, make our special recipe for our epoxy. At that point, we're going to bring it over here to the beam, and we're going to apply it with the high millage of anything on the 80 mils to make sure that we're going to have enough epoxy to impregnate that sheet. So we're going to bring the epoxy over here. We're going to roll it into the area of the substrate before we're laying up. And then we should have enough epoxy for that sheet left over in that bucket that we can go back over the top of it and impregnate it from the reverse side of it from above back into the product, if that makes sense. So in this one sheet, 1 foot, 3 feet long, I would say we're plenty good at 16 ounces. Eric, would you like to do 16 on that one? Okay, so it doesn't matter A or B which one you dump in first, but one thing it does matter is we do not want to get it on the sides of the bucket, the mother bucket. We always want to dump vertical into it to hit the bottom without the sides so we know we get 100% mixing value out of it. You got 16 ounces there, double check, looks like 16 right on the money. Dump her in. So our mixing time is 3 minutes per full unit. Break that down on volume, it wouldn't be that much if we're only doing 16 ounces. We just got done mixing. How we can tell it's a really good mix job. He did it by the time frame that was recommended by the product manufacturer, Rhino, and it turns into this white milky stuff that does not end up being that way. It actually dries clear. It is mixed and it's hot, so we want to go ahead and get it on the substrate. Okay, the little tray thing right here. Do you want this to do a bucket one?
Yeah, insert.
Sure.
All right. With some lumber on.
We're going to need this one in the ditch and put a lot of Time is essence. As soon as you mix it, you want a crew ready to go ahead and put this down. I made marks on this beam where the first sheet's going to go. I would normally have a millage gauge with me right now looking at it. I always tell everybody if it's running down the beam, that's a good sign. If it's not, you need more product. More the merrier. You cannot put too much on. We'll put it that way.
You got the other roller? You want to hit that backside?
You need another roller?
You get it. Okay, and I'm going to finish the bottom here.
It is runny and messy stuff. That's why we're wearing tie-back suits. It's not a clean dealie, but. Okay, so we're ready for layup. If you notice, I grabbed this sheet. I wanted to make sure my hands are clean. I'm not touching any other sheets. If I get epoxy on them sheets, it's going to cause a little hard spot on it, and that sheet's worthless. So make sure that you're only saturating the sheet you're using at the time. And one thing we want to do is now rib roll this sheet to open up the toes of the carbon fiber and to make sure that we're impregnating the sheet with epoxy all the way through. We want to see bleeding go all the way through the sheet. This is what we call a dry layup. I am running the rib roller with the toes and not against them. And now I'm going to be handing the sheet over to Eric like that. He's going to hold it right there. And he's going to stop. And we're going to go around the corners good. If there's a fell point, it'll be on these corners. So we want to make sure we get them good. There's a little bump right there. If you think you rolled it enough, go ahead and roll again. Okay, go ahead and lay yours. We took the air as I rolled it down. I gave it to Eric. I rolled it out as he hung onto it to get the air out, and then he's grabbing it, finishing it up in the horseshoe pattern. Notice we cut a little long, like we said we knew we were going to be a little longer, and it's kind of came down a little bit. We're still within structural value of the ceiling. This would get cut off at the end. Yeah. Why this epoxy is still good? We're doing a wet on wet process here. So as your epoxy is still good, you go back in that bucket as soon as we got everything out. Is now we're going to make sure that we encapsulate this sheet. You're going, again, rolling with the sheet. This is very important that we're not going to roll left or right. We're going up and down. Same system. I'm going to start bringing it towards Eric again. If he sees any sags, any D-lambs, he's going to start rolling them out. One thing we're looking for is a nice gloss face that there's no dry spots apparent whatsoever. We had a question, is there a difference between the foam roller, the nap roller, or the hard plastic one that we use? There is. The foam roller is just to apply the epoxy onto the sheet itself. The hard roller, these are rib rollers that we use, and what this does is when we go up and down with the sheet, it opens up these toes and makes sure that we have enough pressure to make sure it leads the epoxy through. Great question, thank you. So we had a question from the audience, how important it is to roll out the edges of the carbon fiber, not only for bond, but for safety, because if it does come out a little bit, it's razor sharp, and he had a bad experience and got cut. Absolutely, 100% important. The edge of the sheet is just as important as the middle of the sheet. It's been designed and engineered by the product manufacturer reps of Rhino to use full sheet, and same with the engineer that's working on the field. That's what we want to do, is get the corners down, the edges down, and the whole sheet. Great question, thank you.